Uh, I also come from China, Henan province. You can see in the left figure here, it's in the heart of the China. It's famous for some Shaolin temple, the Shaolin Kung Fu, as well as some Logman growth, some quite old history, long history, the statues. Uh, so this is generally about myself. So hope we can make more connections during this class to learn some new things to yeah, as well as before I finish myself, I also want to know you guys. So I hope you can do a simple self-introduction about yourself, like your name, your job, or anything you want to share with your classmates. Is that okay?
Okay.
Yeah, maybe this gentleman
Yeah.
first. Yeah.
Yeah, my name's Dan Hobson. I've recently relocated here from the UK in August, so I've only been here 6 months.
Okay.
Yeah. Yeah, so I've started my new job here only last week, so fresh. I'm on the Jurong Region Line.
Okay.
In Bukit Batok. I'm
Okay.
a senior engineer on that project.
Oh, okay.
I came, my history in the UK was all civil major projects. So I think over 12 years, 4 projects.
Wow.
All, 200 million plus, just big, crazy, complicated, spinning plates all the time. And I tried to vary my experience from construction type to construction type. So there's a lot of value from shared knowledge from different industries between rail, underground, above ground, airports.
Oh, I see.
I'm starting to find there's a similarity here where maybe there's silos. People build trains and railways, they don't talk to people who build roads. And they can share a lot of knowledge.
Yes.
That's why I tried to do that.
So,
Hopefully.
yeah, you're quite experienced. You have so many experience work. Yeah.
It was only when I got to Singapore and they were just like, you don't have a degree. Oh man, I have to sort that out. So then I found out it's been 10 years to be slow going. Grease the wheels to get the brain working still. So.
Yeah. I see. But I think the real project experience will help you a lot in this course.
That's the benefit. I think that's the benefit of this kind of part-time learning is if you're able to put what you're learning into practice, you understand why you do it. Whereas I think doing a degree at the start of your career, it's harder to appreciate why it's important.
Mm-hmm.
So I've all of my education's been part-time, like since I've been on site since I was 18.
Wow.
Just doing things.
Okay.
Things. So,
that's quite different in Asian culture, I think.
Yes. Yeah, it's very. It's a different way of doing it. I think it's very experience-based versus education-based. So molded the way that I approach construction as well.
Yeah. Okay. Yeah. Thank you very much for sharing. Yeah.
My name is Rajesh. I'm working as the RTO in Singapore.
Sorry, you're working at what?
Resident Technical Officer.
Oh, okay.
I have a work.
Okay. Nice to meet you. Yeah, Sen.
Yes, my name is Yutago. I got a geology degree from.
Oh, you got a geological?
Yeah, geology.
Wow, degree.
Specialty is geology.
Okay, I see.
I'm working K103 Jurong Regional Project.
Also in Jurong.
Yes.
Okay, I see. You are actually quite experienced than me because I'm more on the research track. Yeah. Then this one?
My name is Ian Capital. I just started working as a site engineer about 4 months ago. So I graduated with diploma in construction engineering.
Okay.
A few months back.
Okay, I see.
But only starting to amass experience.
It's okay. My experience is much lesser than you, I think. Okay, this one.
My name is Wayne. Actually, I graduated from the BCA Academy.
Okay.
Construction engineering course. So now I work in the construction industry almost 3 years. So right now I'm the site engineer at the MRT project.
Oh.
Scotland.
Okay, North Sea Coastline. So is it the LTR line or LRT line?
LRT.
LRT, I think it's another Green Line, right?
No, North Sea Scotland.
Yeah.
team.
Oh, okay, okay. Yeah. I see. Okay. Then the last one.
My name is Tan Chong. I working in the MRT company.
Also MRT. Okay, I see. So as you can see, actually, you have a lot of working experience than me actually. So maybe I'm just a fresh in front of you. You are quite experienced engineers, or have a lot of the set experience. But that's why I also hope in this course we can learn from each other because I'm more on the some deep understanding of the mechanisms or the why we do that and the new structures we will use in the future. So you can learn from each other. So please feel free to contact me if you have any questions or problems. So the email or the WhatsApp. Okay. Thank you very much for your sharing. Hey, we still have another one. Sorry. Online. Mayo Coco.
Yes, evening.
Yeah.
I'm working in the Thimphu, the CNS, the professional construction site as a resident technical officer, and now working on the North Corridor projects.
Oh, okay. It's also a Northeast project.
North Corridor. Yeah.
Okay. I see another one. Okay. Thank you. So after we do this, I also want to highlight some time schedule because this course is no exams, so it's just the course work based. So usually you will do some calculation or some design using the software to do some design work. So also it's around 2 months the schedule, and usually it's sometimes like the 1 week we have to not Monday, Wednesday, but sometimes we will have some on the same day, especially for the computer labs.
Okay.
So you can see in the schedule it doesn't have the online learning course. So online learning lesson actually is up to you. If you don't want to, you're tired, you don't want to come, you can just from home. But I will come here because maybe I need a whiteboard to write something, to explain something. So it's different to you. You also can come to the class. It's all different to you. So the deadline for the course submission date is the 20 May. February is 20 May is a May. Yeah. So any questions relating to the schedule or the myself or any other things? Okay. If no, we can start to do the year 3, level 6, the introduction of civil engineering. Actually, when I first get the course like schedule, say I need to teach year 3, 6 starting the course. I feel not so confident, and I prepare a lot because I think my experience actually in front of you is quite less. So I try my best to incorporate all the information to you to help you to understand the standards of course. Because usually I teach is quite the year 1 or year 2 course or the diploma course. So this is my first time, but I will try my best. We will work together about this course. So as we can see in the level 6 is different. It's usually professional for the professional world. It require a lot of the independent effort, research, and the supervised process is high level autonomy, initiative, and independence. Sometimes it's like our research work is also new, to be independent. Not like the year 1 or year 2, we get you to do this, to do that. So the year 3, we also need to practice our self-learning skills to understand more, to explore more. And we totally have 6, including the honors project, individual honor project, group honor project. So today we will learn is about the structures too. And also, I think maybe in the future we will teach the advanced analysis and design methods. And I hope already done.
Yeah, half and half.
Half of people we done already.
Oh, you already done this.
Half of people, half new set.
Okay. So I think after that you may need to do the individual honor projects. So that I think maybe in the future I also will teach this one. It's more like do some experience or research on analytical numerical projects. So key skills in independent research, own deadlines, measure or your own workload, built on given knowledges. So we see it's like the supervision. It's not a demonstration, every example or something. It's more like you explore. But don't worry, I will be here. We will work it together. Then the aim is be ready. Then because usually like in the you already have work corrections, but like me in my year 3 or year 4, we must learn some things. We must be ready for the professional work, the real engineering practice. Yeah, so acquire the transport skills. So outline of this course is like concept design of the structure, loading, design actions, timber beam design, RC reinforced concrete slab design, steel beam column, composite structure design, finite element simulation using ANSYS. So has anyone have any experience about the finite element simulation? You have, right, Daniel?
Yeah, we did it for the design analysis module.
Oh.
We did it just before, where we did it with hydraulics. So it's the influence of fluids on structure.
Okay, it's hydraulics.
Yeah.
So in your real working experience, do you touch any finite element?
No. It's,
okay.
Way outside of our wheelhouse.
Oh, okay.
Yeah.
I see.
In the designers world, and we ask the question, why does this not work? Please tell me why this doesn't work.
Yeah, this
so
is.
That's, I think that's where we end up.
Yeah. So any other classmates have any experience on the finite element simulation?
No.
Okay. So it's quite a new topic for you. So before we do that, actually, I don't have a quite clear about your background, like the mechanical background or your understanding of the basic concepts in the civil engineering. I hope you can encourage me to do a small game-based test. It's a simple one, no any marks. It just let me to understand your background more, so I can adjust my pace, even my schedule, organization of the slides to help you to learn more and easier. Okay, so if okay, you can Google search using your phone, just using the phone. You can so play Kahoot. Mayo Coco.
Yes.
You can see my slides. I hope you can also participate in the small game-based test. You can Google search the play Kahoot.
Kahoot. Let me try this.
Using your own phone.
Yes, I'm now using the phone only.
Okay. So you can you will see the Kahoot. You will enter the game pin. So you can enter the game pin. It's 140953. Okay. Actually, see 4 classmates join this one. And you know, Rajesh. So it's go back. You can Kahoot. You will play Kahoot. You will enter the first. I think the first one. Let me show. Okay, I see then. Play Kahoot in. Hello. Okay, just nice. Uh, 140953. Hello. Our new 2 classmates. So I let you to play a small game-based test. It's just for understanding your background, your basic knowledges. So no any marks. Just let me know more so I can make the schedule or the organization, the structure of the slides more easier for you. So you can just using your phone. and Google search play Kahoot. Then you enter the game pin for 140953.
Hello, is any game pin? I saw the game pin to the need to insert.
Yeah, you enter the games because you see I will let all you join, then I will do the I will start. You will see the games, then you choose the right answers using different colors.
I saw the page is need to enter for the game pin.
Yeah, the game pin
Pin
game pin is 140953.
140953. 140
953.
or 953. Okay.
Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So ready? I will start the play games. Then you can just tap the correct color. Because different color means different answers. You click the color. You can see the first one. You're just using the phone, no need to see the screen. Question is here also. The question is on the top moments. Like we always see the mechanical moments are vector, scalar, number, or none of the above. You just using the phone click the red answers. Just a key you think it's correct. It doesn't matter even you get a like low number or something. It will not show your marks, your numbers. It only show the highest one. It doesn't show the lowest one or ranking. So I will get a report through this small game test. So I will see, okay, your understanding which is not so solid. Then I will enhance in the learning process. Okay, I get Mel Coco, have you entered the answers? You know how to enter the answers?
Yes, need to choose the triangle or rectangular or something because just now I go down my list, the connection something lost.
Okay. Okay.
Yeah, I know I choose already.
Okay, no problem. So now after you all key in your answers, it will jump next question.
Yeah.
Okay, the done is the highest one. It will accumulate your marks, your points. So what is cosine theta in this triangle? You also can take note if you are wrong or if you don't understand. You can, after class or during the break, we can discuss. I just hope can get an overview of your skills or something to help you much easier.
The second answer I choose very best stay loading for the classroom prefabrication.
Sir Mayo Coco, you're talking to me?
Yeah. Second question I already answered, but still loading in my screen classroom preparation.
No problem, because we have eight 8 answers. Usually, I think 9 answers or 8 answers. All submit your answers. Okay. Okay. So we go to the next questions. So this one is, have you seen a report? So now the key climb up. So vector, the C is equal to A plus B. So this is A vector, this is B vector. What is C? Vector C is equal to A plus B. We have 6 answers. Okay. Okay, no problem. Pin is 140,953. Okay, we continue next. Total, I think around 10. So then climb up again. The safety factor for the steel strings. Not sure you have remember this value, or whether you are familiar with what is safety factor for steel strings.
It'll be the connection.
Oh,
Sorry, it's got a bit loose.
sorry. Okay. I have 5, 7. Okay. At least you should understand what is safety factor. So this is more important. The value maybe you not remember so clearly. It's okay. So I want to highlight is a safety factor. Never mind. Oh, okay. The new one come up. Let's see one. The main failure of the cylinder beam, cylinder column. Is compression failure, buckling failure, or bending failure, or none of the above? Cylinder column. So some concept is a cylinder one. You see, yeah, never mind, it's okay. Okay, let's see the next one. Retaining wall, it's more like some geological or something. Retaining wall, I think the okay, this one actually a lot. Okay, let's see the 7. This is another definition. It's maybe some basic one. If you don't know, it's also okay. It's just to let me know your background or something. Short embrace column. It's okay. Just think it's a game. It's a anything. It's just a I will see the report. It's very useful for me. So try best to do. Okay. I think it's just the value lah. You know it, choose the smaller one. Okay. Support reaction forces and moments for the fixed end. What is fixed end? Reaction forces and moments for the fixed end. We have the roller supported, simple supported, pin supported, and also fixed end. Okay. So, okay. Okay, still up here. See next one. Equilibrium of the structural member should satisfy. What is the equilibrium of one structural member like the beam or column? What is the equilibrium of column or beam should satisfy the equation? I think this one is just a definition. What is equilibrium? Or how we do the equilibrium equation. Okay, might come up. Let's see next one. Because it also depends on your speed, also correctness. So it's give the marks. This is sorry, the picture is maybe too small. It's a simple beam under the center concentrated load. So what is the maximum deflection occurs? Some concept of deflection. Okay, so this is okay, done, comma. Okay, final two. Which one is the serviceability limit state? I'm not sure you are familiar with the serviceability limit state. This one we also will explain today about serviceability. Okay, only one. No problem. Today we will explain more. Might come out. So last one, let's make it quick. Concept of reinforced concrete. So any understanding about the concrete, reinforced concrete is correct. Okay, actually all the is correct for reinforced concrete. So let's see the final one. Okay, that is ranking the number one. So good. Actually, it's correct 8 out of the 12. So 2 and 3 is math, and Alpine is 7 out of the 12. But it's okay. It's just for small game to check your understanding or something. It's just for me to see the. For example, I will see the report. It's for me about your understand, especially like the mathematics or the concepts or any the mechanism you don't understand. So something I will highlight and enhance in the slides. Okay. Okay, so this one also you will check. This is some maybe some how say the fundamental concepts we will use actually in the design, the work. Even we use some the moment diagram or the shear force diagram we will use. And also in the even we use the software, we don't need to understand so much, but better for the engineer, we understand the background philosophy behind the software. So we can also check by yourself to know whether the software is correct or not. So it's not just learn how to use the software, to understand the mechanism. Okay, thank you very much for your cooperation for participating in this the small games. So for these lessons, we will focus on some standards starting from the EN 1990, the basic of the design, concept design, and also 1991, the actions, and also concrete, steel, composite, timbers, masonry, aluminum. But actually, the aluminum and masonry will not focus so much. And also, this is some in the let me see. Michael, maybe you can mute yourself if you don't have any questions.
Okay, thank you.
Yeah, thank you. So for all the standards or codes, actually for me to learn when I was an undergraduate, it's a lot of new parameters or the indicators and also some concepts come out here, then go to another standard code, it come out again. They have new understandings. So actually it's just some complex or repeated work for you to learn the standards or codes. Here I'm just try my best to organize, to summary all the key things in the standard and codes to help you to understand. So my slides actually is a little bit different from your slides from you can download from the online because I added more slides or examples or information. I think it's quite useful for you. So I will share the slides after the classes. Because the class maybe also have made some errors, I will need to do revision and I will send to the group chat. You will also can use this one, but it's more material than the online slides. Okay, before we start, so now we are actually ready to start out the full course here. We're starting from the type of the construction. So usually we will focus on the reinforced concrete construction and also the steel construction, timber construction, masonry construction, steel and concrete composite constructions. I think it's just a common terms like reinforced concrete or something. So actually here in course, I will ask you questions to inspire you to think the understandings, to understand more deep. So for example here, anyone can tell me what's the difference between the reinforced concrete construction and the steel concrete composite construction?
So the closest would be metal decking with a concrete slab on top that uses the shape of the decking and then the thinner reinforced concrete together to work rather than being one reinforced encasing it.
So this is steel concrete composite structure or reinforced concrete structures?
It's the composite one.
Composite one. Okay. Any other students have any ideas about difference? Like what is reinforced concrete? Maybe you will see a lot in your, like the HDB building construction, you see a lot of the reinforced concrete structures. So, but also nowadays, actually in the frontier of the civil engineering, more work is on the steel concrete composite constructors. So because it's more for the prefabricated modular construction concept. So
the pre-stressing work.
Yeah.
Put the pre-stress the slab, then use the HDB
Yeah.
for the precast beam.
Yes, yes. So it's, you can see, I think in the new HDB building, you also can see, like in the Pongo, in the Senggang, they do a lot of the modular construction. They just using some of the track to hang it up, to put it on the stories.
Yeah.
So they do legwork.
Precast material, composite of steel and concrete.
Yes, it's quite fast. So as we can see, the traditional one, we see a lot of reinforced concrete structures. So the red picture here, you see the difference. If we do not have the outer layer, you can see the outer layer actually is a steel plate or steel tube. If we don't have the steel plate or steel tube, we only have the concrete with the steel rebar. We usually call this is reinforced concrete structures. This is for column. For beam, it's similar. But for the composite structures, usually we have some steel plates, like Daniel said. Maybe have some, like especially for the bridge. So if you have the shape, this shape to and put it on the steel plates, it will have the concrete. So many different steel composite constructors that have the steel plates, not only the steel rebars. So this is quite hot research topics in the civil engineering. I'm not sure you hear about Richard Liu. He is a quite professional engineer. Also, he's a full professor in US. He's quite famous for the steel concrete high strength composite structures construction. So, for example, the steel composite, steel and concrete composite structures is usually a lot of used in the bridge structures, highway, railway bridges. It is higher span to depth ratio, reduce deflection. So deflection is actually just to highlight. Oh, sorry. The deflection as the question is just like we have a beam. So if we have a concentrated load, it will like have a curved shape. So we call this one that is a deflection. So it's just a deformation. So through these structures, it will reduce the deflections because deflection actually is a design limit. It's a serviceability limit state design. So we want to reduce the deflection. So this figure is some in the US lab we have done. Like this one is a quite common steel studs and shear connectors connect the concrete with the steel plates. This is the typical one, the beam, the composite beams. And this one is another project. It is for the PAL. Actually, this is for the PAL. It is outside is the steel tube. Inside also a steel tube. Then between them, they have the concrete. So this is a typical steel and concrete composite structures, a little bit different from the reinforced concrete structures. The design situation in the codes or standards, usually we will need to consider all the different design situations, starting from the transit design situation. It is a period much shorter than the design working life. So usually it's like during the execution or repair. It's a short term. It's not after we finish the construction. It's a long term. It's a short term. Then the persistent design situation is a long term. It's usually like we finish after we do the execution or construction. The HDB must to have a design life like the 50 years or the 90 years. So these are long term effects. And also in like Indonesia or in Japan, in China, we will have the seismic design situation because the seismic will cause quite large damages. And accidental design situation. Actually, for this one, in our construction, we will consider it, but it's more common in the defense construction. It is a civil defense areas, especially for some explosion, fire resistance, some fire or things. So in Singapore, the civil defense, we will have we have a lot of projects from the civil defense. They do the concrete to check the concrete if you have the bullet or have the mill on the concrete, how the behavior of the beam or the walls, the columns under this explosion or attack. So actually we have different design situations in all the design standards or codes. But mostly for today, for these lessons, we'll mainly focus on the persistent design situation. So it's a long terms, not consider the seismic or accidental design. And these are some no need to remember, just to show you here some general assumption. It's always like when you using the formulas in the standard or course, we assume you already have some quite professional skills. You understand the parameters meaning, not just use it. So it is execution is carried out by the person who have the appropriate skill and experience, not by a high school student or something you don't know anything, you use it. Because usually the standard and code, they have a limitation. They're too conservative. Once you change something, it will cause some disaster. So we assume you use this standard codes, you have some professional skills and experience. And adequate supervision and quality control is provided during the design and during the execution of the work. So actually, as a design engineer or the structural engineer in the design phase, their responsibility is quite important, because almost 20% of the failure, like for example for the bridges, is caused by the design civil engineers. They do the wrong calculation, or they didn't consider so much actions in the reality, so they will cause the failures. This is some requirement. It's similar. It's sustain all actions. I just read. No need to remember. Just understand. Meet the specific serviceability requirements, structural resistance, serviceability, durability. So resistance, serviceability, and durability. So structure be designed and executed in such a way it will not be damaged by events such as explosion. This is accidental design, impact, and also the consequences of human errors. So any students can tell me your understanding of the human errors in the design or in the construction. Have you encountered any human errors cause the disaster or damage of the structures?
Yeah.
Such as?
Well, it wasn't damaged. It was setting out errors, put piles in the wrong places. So they had to recheck the beam to see if the span still worked with the pile in a different location. But the beam still worked because of the kind of safety factors.
Okay.
So following the check, it was okay, but the safety factors allowed the capacity in the beam when the pile was in the wrong place.
Okay.
It worked, but it was purely down to the setting out error.
Okay, I see.
Human issue.
Okay. Any other human errors you think or you encounter in any phase? Okay, so first I want to show a figure here. This is from some research papers or the summary report. It like the main hazards source leading to the bridge failures. So it is like we have the error, design and construction errors. So this is usually the main cause of the failures. Then after that is natural hazards, operation errors, and human-made hazards. So I summarize the 3 types of the human errors in this one. It's like the design construction errors. It's like the construction negligence. You forget something. Like, for example, the concrete, usually we do maybe let it settle down in around 28 days or something, but you think you must meet the deadline. So just have maybe 1 week, you do another level, do another story. So it will cause it causes a lot of potential failures in the future. There are also some operation errors. So overloading by the live load during inspection and maintenance works, corrosion, especially in Singapore, we do a lot of work in this offshore and marine. Offshore and marine because it's always in the water, undersea. So corrosion is quite important factors we need to consider during the operation of the marine and offshore structures. Now, there's some human-made hazard, like the ship collapses, because there are some news like the ship collapsed on the bridges, and also some failed vehicles, explosion or terrorist attack. So there are some the summary of the human-made errors. Okay, so it is also another requirement is choice of the suitable material, apparel design, detailing, control procedure, design, production, execution, and use relevant to the particular project. All these things actually you see just some words, but now it all is some research topics or some engineering topics we done, like the choice of suitable materials. We now is developing some new 3D printing concrete or some concrete made by the waste, like solid waste to use. So the choice of suitable materials. Appropriate design and detailing. I'm not sure you encountered some BIM, building information modeling techniques. So this is some usually we want to do the design, combine the design, the construction together in a software. So now we are also a quite hot topic is about the BIM, and also the specific control procedure for design production. So it's like automation or tools of the different production execution plans. So these actually a lot of work behind these different requirements. Okay, next is reliability. Do you encounter any reliability concept in your life or in your experience? Or do you think why we need to consider reliability? Any ideas or?
More cost reliability is controlling the cost of this project.
Sorry,
Controlling the cost of the project.
controlling the, okay, maybe any other source? Reliability.
Being able to plan. If you know it's going to happen consistently, you can be efficient. So you can make something cheaper over the long run. You know it's going to happen. You know it's going to work that way. And on the might be a system, it might be how a beam works, reduce the maintenance, paint spec, all those kind of things. You know it's going to work for a certain period of time. You can plan ahead and make that more efficient over the long term.
Yeah, but it's a good try, but it's not the why we need to consider reliability. Yeah, you make plan is good to make it efficient and secure the schedule or something, but actually not so why we need to consider reliability. Any other source reliability? Do you think the reliability, the meaning of the reliability? Okay, let's see this one. Okay, for example, today I assume all your 10 classmates will come because Fatima told me, okay, already 14 students will join this course, but actually today only come to the classes 1, 2, 3, 4, 5, 8 students. So always when we design, we assume a lot of things, but actually it have a lot of uncertainties. This is the uncertainties will cause the reliability issues. So we build these buildings. For example, in Singapore, we no need to consider so much of the seismic design. So we build this. Hi, yeah, take a seat. We build these buildings. We think, okay, we no need to consider seismic design, but actually, just a few days ago, I'm not sure you can feel the seismic action vibration in your house or in your office from the Indonesia. There is a 6.5 great earthquake. So actually, it's with design, we think the situation is not seismic, but actually it will have some seismic. So this is the reliability comes from because we cannot predict the future situation quite accurately or have a 100% confidence. So this is where we come to reliability management. An interesting question is about, do you think Singapore should have the nuclear energy or not?
It's small. Yeah.
Why?
Safety factors if it went wrong. Too close to everything. you look at where nuclear is.
Density
in
of
other
people is
places.
higher.
Yeah, so
Small,
normally
Too
it's-
small,
it's
then
far
stay
away.
higher.
Just because of the potential impact of failure.
Mm-hmm.
That's the issue. But
Yes.
maybe the mini ones. Were they talking about small city-sized nuclear stations? They're talking about that in France about making these
Mm-hmm.
small ones that aren't the size of cities. They just they can power a small city. Maybe that's the way it should go. But,
Yeah. So actually, we have this one. You think it's we have a seminar. It's about talking about whether we should have the nuclear energy in Singapore because Singapore is short of energies or electricity. But because as you see, the density is higher, the land is quite small. It's not like in China or in European, they have a quite large land. So you can see here the table show the nuclear power reactors. We must have the extremely high reliability. We must make sure nothing will be wrong. Everything should be 100% okay. But still have some errors or disaster in the history, like Russia have some nuclear leak, so issues. So for Singapore, because it's too small, we cannot move forward to other places because nearby is another country. So that's why Singapore they cannot have the new energy, the nuclear energy to use. So all these design or the reliability issues, you can consider the plan, how they plan Singapore development using what energy, like the solar energy, it's more clean and safe. And they also will consider some water energy, but it's not so popular like the solar energies. So that's why how they plan account for the reliability issues or the probability issues. So this is some the table show here for your reference, just some different reliability degree for different buildings, like the nuclear power is high, quite high. Then the significant bridges is quite high because once it broke down or it fails, it will cause a lot of economical and the people's lives are lost. For the normal like residential or office buildings, it's just a medium. For the low one, it's just some like the lightning columns, so no any like the people involved. So we have the low reliability. No need to so careful or so sure of the safety of the buildings. Okay, maybe before we actually take a break, we see a small video just to give you a hint of the next session of this one. Okay, so this is the video simulate the Titanic sink. So what so this question is like what types of failure what type of failure are in the Titanic sink? What do you think the cause of the failure of the Titanic, or during the breakup, what failure or what consideration or what mechanism caused the failure of the Titanic? Any ideas?
So the pollution on the iceberg,
Collusion on the iceberg? Yes.
then leakage, flooding,
Yes. Any other thoughts?
So as soon as it lifted the tail into the air,
Mm-hmm.
it couldn't take the bending, so it
Bending
failed.
moments, yes.
So the ship itself was designed for that much weight cantilevered from the sea, at which point it.
Okay. Yes. This side. Any thoughts like this is collision or maybe the bending issues or leakage issues or any other thoughts you think or what you can learn from the when you design in your assignment when you design what you want to consider what failure through this Titanic sink. Don't be shy, just express yourself. It's okay. I'm also quite shy before I meet you. I'm quite nervous actually.
They always said that the reason the Titanic failed is because it went across multiple safety factors, failed at the same time. So they were never expected so many compartments to fill up with water in one event, which then eventually caused it to dip below the water, then it just accelerated from there. So it filled up with more water, got heavier, and then went. It's that Swiss cheese effect, that we say back home, where a failure always happens from multiple failings, where it bypasses all of the safety nets you put in place. So there's a small percentage that will happen, but it still could happen. So it's the failure of multiple safety nets. So like it was 5 or 6 compartments filled because of the damage along the length of it. That then just hit the balance. To get it down.
Okay. Yes, true. So like actually I want to add one is about the not only the collusion or the bending or the you can see the cantilever in the water, then the bending strength is not so good. Also it's about its loss of equilibrium. So once it collusion to the iceberg, so they have some water inside pumped into the ship, the tank. So then it will lose equilibrium, because when we design the ship, they never expect like so much water in the ship, so it will become to rotting, non-stability. So the rot, then because of this rot, it's like have the bending the upper part have a quite heavy, so it will bending. The bending strength of the ship is not so strong to meet this so big heavy parts, so that's why it breaks down. So actually it is a series, like you see, a series of actions together to cause this failure of the Titanic. The first one is collusion, next one is loss of the equilibrium, second one is like the bending strength. The strength is cannot withstand the whole heavy front part. Yes. So it is also we will learn in this course about these different designs, including the loss of equilibrium, including the strength issues. But about the collusion one, we will not consider so much because in the civil engineering, in the HDB or framework building, we don't consider so much on this one, at least for this work. But of course, it is a research topic you need to consider. Yeah. So actually, this is the first session for today. I don't want to make it too heavy for the first day. And before we end, I also want to invite the 3 classmates come to late to introduce themselves, because we all introduce ourselves to other classmates to understand more. Okay, lady first.
My name is ACCL.
Okay.
I graduated with construction engineering, but currently working as a technical engineer.
Oh, mechanical engineer. Yeah. Okay.
My name is Chu Pizong. I'm currently working as an engineer for a commercial project.
Okay.
And Joseph Arul Makindraga, currently working for HDB in Nazareth.
Oh, okay. So actually, like I say, you all have a lot of working experience than me. So for your information, this is already shown in the first slide. This is my contact information. So I leave it here. If you have any question, you can WhatsApp me. Also can email me. I'm available to help you to any issues or problems. Okay. Any questions relating to the first part of today's lessons? Too fast or too slow or too heavy? Okay. You have any feedback, just tell me. I will adjust my pace or my schedules organization. Okay, so this is the first session. You can take like a 10 to 15 minutes break. Then we continue to the second part. Okay, thank you. Yeah, sorry. So this is the attendance. You can take the attendance. Have you guys have the link to download the Europe codes? Like the EN 1990 to EN 1997. Okay, I share this link to the our group chat, so you can through this link to download all the Europe code. Once you find this link, actually the most useful one or summary one is the Europe code basis of the structural design. So let me show here. You can download all the things. So like this one, you download it. So for the Europe code basis of the structural design, so there will be a file is the structural Europe code. It is a summary like different 1990, 1991. So it's more summaries, how to say, compressed and concise work of all the Europe code. So you can learn from this one, just through this one, Europe code, to learn the new concepts, to understanding, because every Europe code you learn, every Europe code, a lot of concepts, too many formulas, not easy to understand. I suggest you use this one first. It's in the link I sent to you is the in the Europe code basis of structural design. Then if you have the structural Europe code, the 1990, this one extracts from the structural Europe codes. So this one is maybe at the starting point, it's more easier for you to learn all the key things or critical things of all the Europe codes. But it still have a lot of formulas or the concepts to understand. So actually for you, I believe for you guys, the course is actually just the work, just some efforts to read it, understand it. No different, not so many difficulties. So just starting to read it, to understand it, for this course, actually our design is only this is 3-story frame design using the ANSYS. It's much easier just using the your course. It's just using the software. The money in the software is like how to build this geometry, how to give load, how to do the analysis, set the boundary conditions, then let the software solve the other things. You will get the solution. Every location, the stress, displacement, strain. Because it's not so much relating to the analytical or mathematical issues. If I think all come back, maybe we can start to the second session. And Coco, are you back?
Yes, I am back ready.
Okay, sure. We will start the second session. Okay, we will next session mainly focus on the limit state design. So this is the main concepts or key concepts in the design. So I'm not sure whether you heard this news. It's in the Miami Beach, Florida, in USA, in the June 24, last year. It's 12-story condominium buildings suddenly collapsed. Part of the building collapsed. So this is the already filled buildings, If you draw the original one, it looks like this. Almost the half this area is collapsed. And this one is a quite typical one, the frame buildings. So as you can see in the red one, the structural design, structural drawing, it's just a lot of the reinforced concrete columns, beams, and some walls. So typical one. So this is more complicated one than our assignment or coursework, but it's also the one to show us how we should design to avoid this collapse based on the limited state design. The limited state design will divide into two parts. It is one is the, let's draw a framework for today is the limit one is we call the outer limit state design. Okay, this is the first one. We call out limit state design. It mainly focuses on the four parts here in the slides. The first one is the EQU. Actually, it's a loss of the equilibrium. So you still remember in the small game, we say, okay, the equilibrium equations, how we do that. So this is the first one, equilibrium, loss of the static equilibrium. So let's see the words here. This is from the course. It's a loss of the static equilibrium of the structure or any part of it considered as a rigid body. Do you guys have understanding of what is rigid body? Rigid body here. Okay. Rigid body. Okay, let me. This one is a rigid body. It's quite easy to bend, right? But maybe for this pen, for me, it is rigid body. It's not easy for me to bend it. So this one say it's a rigid body means the stiffness, or you can think the Young modulus is quite large. So in this way, it's not considered as the I figure it. It's like, for example, I put it here. This side is heavier. This one is lighter. So they will jolt. It will not stable. It will not stability, not stable. So this is the loss of static equilibrium for the structure. It's like for the rigid body, it's not bending failure or strength failure. It's just it's not stable here. It's quite easy to lose the stability of this structure. So you can see the rigid body where the minor variation in the equilibrium, the spatial distribution of the prominent actions from a single source are significant. For I say here, if I put here, if nothing happens, it will stable. But once I give a load here too large, it will stable. It will not stable. Sorry. So this is the caused by a single source are significant, and the strength of the construction materials or ground are generally not governing. So you can see this failure is not because my load is too heavy to bend it, to failure it. It's because just a single load will cause the non-stability. So that's why they say the strength of the construction material are generally not governing. So this is the first one, stability. Stability usually we consider is a ground. We call the ground is an uplift, because usually the ground, the foundation part, for example, this is the pile, this is foundation. Okay, so this is the soil. For example, this one, like if this point or this area is suddenly settled down, so it will cause the foundation or the column will rotate like this. So it will not stable. So this is a loss of equilibrium. And this loss of equilibrium are quite common in the foundation and also in the marine structure like the ship. You can see in the video some of the quite large waves. The ship is like rotating here, rotating there, but it will stable. This is the first design in the marine ships or the structures in the wave. Also need to consider the loss of the equilibrium. We call stability. The next one we call is STR. It means the strength. A typical one, it means internal failure or excessive deformation of the structure or structural members, including the footings, piles, basement walls, where the strength of the construction material of the structure governs. So this failure is because the failure of the strength. I can bend it to fail. It's not because stability. It's just because of fail. Or like another, like if the paper, I can tear it up, tear it two parts. So it's because of failure of the strength. I give quite a large load to make it break up or break down. So for example, still we say, for example, this column. If no settlement here, no blue line, but I give too large load in the column. For cylinder column, it will have the local buckling, so like here, it will not stable. But if it's too large, and we know the material, usually we will have a material line, like this is strain, this is stress. Material properties, we have the linear elastic part, plastic part, the failure part. So once the load is exceed this point, the material will fail. It caused by the strength. The material or the strength of material is not so large. So this is second one, STR. The main difference between the equilibrium and the STR is this. The third one is geo, is the failure or excessive deformation of the ground, where the strength of the rock, soil and rock are significant in providing the resistance. It's mainly focused on the ground information. This one we will not cover too much on this course. And also the final one is the fatigue failure of the structure or structural members. So anyone give me some ideas what is called fatigue failure? Not because you're tired or something. Fatigue failure. Why you feel fatigued?
Used so many usage. We already used so long period.
Okay. Yes.
Old buildings or old structures getting old and it become
good. Old buildings. So actually, my research topic is fatigue. When I tell to my English teacher, I say I'm doing fatigue. He say, "Oh, you're doing fatigue. So how to relieve fatigue of human?" But actually, my fatigue is about the structures. So usually we call the this is GEO. This is FAT. Fatigue is like what? So like the old history. Usually, for example, this is still we say this is a building. People come into the house, it will give the load. People leave the house, there is no load. So the load will have like, for example, this is time. This is the load, we say F. So load will be up, down, up, down, up, down, up, down, up, down, like the cyclic. So this cyclic we call the fatigue failure. So load may be not so large, but because it go up, go down, go up, go down, go up, go down, it will cause small cracks in the structures. So with time passing by a long time period, the small crack will become a larger crack. It's not a sudden failure. It's not the STR, it's a sudden failure. Once it exceeds this point, it will fail. The fatigue is just a small load, but it must have a long period. That's why for the aged structures or old structures or HDB or the old bridges, we need to take care about the fatigue failure. So this is the 4 ultimate limited state design. Fatigue failure, STR, GO. So any questions about these 4, the difference? For different design, we will use different standards or codes or philosophy. It's okay. Yeah. So the question actually asked you here is equilibrium and STR, because usually for when I was an undergraduate, when I first encountered this one is the difference between these two. What is the difference? Next is the serviceability limit state design. So this design you see here is ultimate. This one is serviceability. So this is another part in the limit state design. I call SLS. Actually, this is ULS. So serviceability limit state design. So it refers to the deflection. Remember I said this is a beam. Okay, so this is your force. So it will deform like this, the dashed line here. So it reflects to the deflection. So it's the deformation of the structures. If it is a frame, like two-story frame here. For example, we have wind. This one is the wind load here. So it will deform. Like maybe I use this one. So it will deform. So the serviceability mainly considered is the deviation between the shape between the deformed structure shape with the original shape. So for example, this one, we call this also is a deformation. This is deflection. Beam usually we use deflection. Then column it will have the compression deformation. So this is for the serviceability limit state design. It mainly considered is you can see here, function of the structure or structural members and the normal use, the comfort of people, the appearance of the construction or work. So even for example, it has deformed. The structure is stable, all is okay. But when you as the people use it, you work on it, you feel the deflection too large. It's also not so good for people. You feel scary because as normal people, they are not professional engineers. They feel it's terrible. Another case is like in your living house, you maybe see some cracks on the wall. I'm not sure you see, but my house have some small cracks on the wall. So these cracks, maybe from the normal people, or they don't have this experience or professional, they feel, oh, this building, whether it's okay or not. But this one, the small cracks okay, but we design must make sure the crack is not so big to make the people scary living inside. So this is called the serviceability limit state design. Serviceability limit state design, we have two parts. It's irreversible and reversible limit state design. So this is come to two. And so it will become irreversible and reversible, two parts. So this is the framework from the limit state design. So irreversible, it means some of the consequences remain after the action that exceed the limit have been removed. Do you guys can understand this one or not? Give me some points, your understanding of this sentence. I say the exceed the limit have been removed. So this one, the two is quite okay. It's like the first one, irreversible. It means, for example, I pull.
crack forming in a beam or a steel beam returning to its shape,
Yes,
being irreversible and reversible.
yes. You can use that way. It's like a spring. If you pull it too large load, it cannot come back to the original shape. But if you give a small load, you release it, it will come back to the small load, original shape. So this is the definition or another explanation of the irreversible and the reversible. Okay, so or in another way, mechanical way, we say is one is elastic deformation, another one is plastic deformation. Plastic deformation cannot go back to original. Elastic deformation can go back to the original. Okay. So there will be thinking about which limit requires a smaller action value. Reversible or irreversible? Sorry? How many say the reversible or elastic? Reversible smaller or irreversible smaller, the value? Reversible, yes. So this is the concept is because usually the material is first is elastic, then it goes to the plastic. So the elastic is the value, this horizontal is stress, this is strain. Usually the value is smaller than the plastic value. So the reversible, the load limit should be smaller. Irreversible should be larger. Okay, so elastic plastic is just a, go back to the material mechanism. Okay, so today is mainly this one, the different concept. I hope you can understand the different limited state design, the definition. The formula for different limited state design will elaborate in the next this Wednesday about different equation. But today, first understand the concepts of the different limited state design. So let you do a small question. Which is ultimate limited state design? All these things. Which is the ultimate limited state design? We should consider. Fatigue. Strength. Come on, come on. Stability. Which is the serviceability limited state design should consider? Deflection. Durability.
Local damage.
Local damage. Well, Coco, are you there?
Yes.
Do you think which one is the ultimate limited state design or which one is the serviceability limited state design?
Ultimate limited state design is for I'm thinking is for the deflashing. Reversibility is thinking for the or deflashing crack strength. The fatigue fair resistance.
Sorry, so you think which one is the, so you can choose from the at least the terms here, which one is the ultimate limited state design?
Ultimate limited state design, I think, is the deflection.
Deflection.
Yeah.
Okay, why?
The ultimate design is in out for the the deflection state for the moment, the one just only thinking for the failure.
Yeah, deflection is caused by the moment.
Yeah.
But it's actually the deformation of the structure. So deformation of the structure not relating to the four here, we say the equilibrium, the strength, yaw, fatigue, other all the serviceability limited state design. So in this
I
way,
cannot see
you cannot see.
the book that very small.
Oh,
The
sorry.
PowerPoint slide I can see, yeah.
Oh, sorry, give me. Now you can see.
But still small. It's okay, never mind. Just
Too small.
see the PowerPoint slide.
Later, I take a picture for you. Okay. Okay. So how do you guys think about the ultimate limit state design and serviceability limit state design? So deflection is what? Serviceability.
Deflection. Yeah, deflection means the deforming the shape, the bending or sway or something.
Yeah, deflection is one of the deformation. So it's for the serviceability limited state design. Cracking is relating to the appearance of the structures. So it's also the serviceability limited state design. Strength is we call the STR, is relating to the ultimate limited state design. Local damage also relating to the cracking. So that's not belong any like the equilibrium STR geo fatigue. So it's also the serviceability limited state design. Stability is about the loss of the equilibrium. So the UL or ULS. Durability, serviceability design. Fatigue, ultimate limited state design. Fail resistance is for the comfort of the people, safety of the people. So for the serviceability limited state design. So all these one, only the strength, stability, fatigue belong to the ultimate limited state design. I put a question here because all the words here you maybe have quite clear, so you better to see in your designing in your real life what is the ultimate, what is serviceability. So here, any questions? Okay. Okay, so based on this design, what we need to do is do the analysis of the structures based on different principles. So the structural analysis and design assisted by testing is what we will do, and it is also included in the standards and codes. So the first one, structural modeling. You see, we in the codes or standard, we have a lot of equations, formulas. How these formula equations come from? It from the experience, the engineers, the experience. It also from the structural modeling. So calculations shall be carried out using appropriate structural models involving relevant variables. So for example, we can use the FE analysis to do the structural modeling, which will be done in this course. And also they need to consider the static actions and the dynamic actions. Static actions is like the density of the structures or the self-weight of the structures. Dynamic actions will include the wind load, the wave load, even the seismic load, because the static and the dynamic quite different is about the amplitude. Static, the amplitude or the load is almost constant along with the time. But dynamic, there is some variation. It will show like this. So you can see seismic design, they need to consider seismic earthquake, or even some the wind load. In a bridge, it will have some vehicle load. So it's called the static and the dynamic actions. This one no need to remember, just help you to understand more. Ultimate and serviceability design. This is the general steps here. I show here is for your reference in your future. Maybe you're interested in the research or in more work you can do. The first one, the first step is determination of the loads or the actions. We first understand, for example, we want to build a building in the central Singapore, the CBD areas. So for example, we want to build a 12 stories building condominium. We must understand the condition of these areas. So we need to decide the loads or the actions, whether the wind load is big or not, whether the people living here, how many people will live here. So this is determination of the loads or actions. Of course, in the offshore and marine structures, it may involve the wave-induced loads and the wind-induced loads. In the mechanical, like the semiconductor areas, maybe need to consider the thermal action. It means because for semiconductor, the temperature maybe some go up, go down, go up, go down. It will also cause the deflection or the deformation of the small parts. So we first say determination of the loads or actions. For this part, we need to consider the uncertainties, which relating to the reliabilities, or statistical distribution, characteristic, design values, or these new concepts we will elaborate in the following courses. After we do that, we do the determination of load effect in members. So for example, today we will have a tutorial session is let you self-examine the actions on the 3-story structures. So for example, this is the 3-story frame. We have wind here. The wind is horizontally on these structures. So we need to transfer this load on each member. So for example, this is a beam 1, this is beam 2, this is beam 3, column 1, column 2, column 3, and 4, 5, 6. We need to transfer this load on each member analysis. So this is the second step. It's determination of the load effect in the members. Whether the stress exceeds the yield or it is fatigue or concentration damage, don't care about too much on this one. So this is what we will usually do. Then determination of the resistance of members. Okay, now we know the stress or the load on each member. We need to design the member. How thick, how big of the columns. This geometry of this column or beam determines the resistance of the member. It means, for example, if my column is thick, it can have a larger load. It can resist a larger load. If it's too thin, then it is quite a smaller load on this. So the second step is determination of the resistance of members, which relating to the strength, stability, or level stress, partial factors, so these things. Next is we do the initial design, we go back to do the optimization. We improve our design. Cycle by cycle, by different engineers, we improve it. Finally, we will get a final design of the 3 frame buildings. So it's similar to your how to say, to your work assignment in this course. Other thing, no need to remember this one. No, remember it's a concept I already explained to you. So how we do the design, we have different methods. For example, we can use analytical approaches, experimental approaches, numerical approaches. So this is concept of automated limited state design. I use experiments. I'm not sure you have noticed, seen this one or not. This is the member, small member. So it's clamped on the 2 ends, then pull it. If we pull it, we will get the strain and stress. So it will follow like this curve. As I see here, it first is elastic, then plastic, then final failure. So they have different stages. This is yield strength, ultimate strength. So this is so the ultimate limit state design is for this one. We must make sure the stress on the member is less than the ultimate strength. So it is stress less than the strength. Strength is a material property. Stress is the external load. So these are different methods we do. Do you guys still familiar about this one? The stress is equal to moment divided by the initial of the moment times the y. I'm not sure you still remember. It's how to determine the stress. Maybe I read this one. So we see if it is a beam, if it under the load, so the beam will have a moment. We call this is M, it's a moment. It's a couple moment. Then the stress on this section, the stress here, stress equal to the moment. This is the geometry parameters times the location of the stress. For example, this stress here. This is stress because stress is linear distributed. It's not uniform caused by the moment. So y is this is x. This is y. So based on the different y location, the stress is different. So you can say stress is caused by the moment. Moment is external actions we call. So this is we say the normal stress. Allowable stress strength. Allowable stress we also call it strength. It's a yield strength or nominal strength. Always is a stress should be less than the strength for the design. Then the tau, we call tau is the shear stress. Also, we will have a shear strength. But this is not the design for the basic concept. So always we see the loads, we call it ice, so smaller than the resistance. The red part is the resistance of the material. Left part is the external load. So usually is the load effect should be smaller than the resistance. This is the key principle for all the, no matter it's ultimate limit state down or the divisibility limit state down, all need to meet this one. The load should be smaller than the resistance. Of course, based on this one, we can do a lot of work, even research work, uncertainties of fabrication, because it have the uncertainties. So we will have the probability. No need to remember this one, just for information. It is have a distribution of different members. Sorry. That will come into our safety factor or the partial factors. Partial factor or safety factor is considered the uncertainty in the loading in the material properties. This one we will explain more detail in Wednesday lessons, but it will come in. It is logics is from this one. If we consider different uncertainties, it will come in the partial factor and the safety factor. That's why in the previous small game, I call the safety factor of the steel strength. I'm not sure you still remember or not. Safety factor. Okay, this one. So this is like the experimental test we usually will do, especially for the new structural members or components. First, it's like the small specimens. I'm not sure you can see. This is steel. All is steel I have done. So this is a small part of the steel members. We will do the fracture test. This is the tensile test pole H. Also, this is the tubular joints. We call it a circular tube joints, widely used in the offshore and marine structures. Bending test. Even this is another pushover test. And sometimes you can see the real figure is a small scale of the whole Jacob in the Singapore. The new generation Jacob in Singapore, small scale, we will do the test. Because for some new structures or components, we don't know the performance. We must do some tests. So this is one of the important way we determine the ultimate limit state.
What is the pushover test? How do you do it?
Actually, it's just you can see this. It's a cruciform. It's yeah. So it's like this one. So it's support here, two sides. Then the upper point we give a load. Then it will deform like this one. So this is called pushover. Pushover.
Okay, there's two sides you are hanging, right? Both sides you are hanging.
Yes. So this one we are support. Then we do a pushover. Pushover means just a monotonic loading to make it fail. So this is a pushover test. And this one is you can see it has 3 legs. Jacob. Not sure you noticed the Jacob structures in Singapore. This is mainly for the oil drilling. So they will do a small scale, the 3 Jacobs, to do the test in the water tank. Singapore have the largest water tank in the world, around 30 meters deep in the university to do the test. Experimental test mainly is to determine like the ultimate load, the capacity of the structures, fracture, buckling parameters. Then we will also do some numerical. This is numerical, other numerical. For example, this one, this is also like a Jacob, similar to Jacob. We do you can see a different color. The different color represents different stress levels. And also this one is a tubular joints. And even this one, the failure part, the left figure is a real field. You can see cracks here. It already debond between different members. We also need to do the simulation in the right figure. But this one is in Abacus. We do the numerical simulation to simulate the failure. So numerical way is a simple and cheap way, because numerical is just work in front of the laptop, the workstation, key in the parameters, build the geometry, key in the load, then let the computer solve it. But this one, experiments will take a lot of time and money. So quite expensive, especially for the new structures members. For example, this one, you see the bending test. Only this one is around 30K for fabrication only. So it's quite expensive, we do the test. So this is numerical. For numerical, we will have different software. I hope you also can encounter different software, such as UseForce. This is for the offshore and marine. This is Abacus. Not sure. This is the Abacus. Another one is the ANSYS. ANSYS we will use in this class, and also called the MSc software. So these are different software. They all use the finite element method. Their logic, their philosophy are the same. So they are use the finite element method to do the simulation. We will explain more about how we do the finite element analysis in the computer labs. I think especially for the structural design, for design things, we use a lot of the software to do. Mechanical engineer, I think maybe also need to do the test and the simulation. So in my opinion, the standard and codes are the combination of the analytical methods, experimental and numerical results, safety and economic balance. So actually, it's codes you see is just some formulas, simple formulas, but actually it already summarizes all the engineers' knowledge, research scholars' knowledge, even the designer knowledge together to give you this formula for you to easy to use. So go back to the structural engineering process. Is first a conceptual design. Is we first want to know what we need to design, what we want to build. Whether you want to use the design in the MRT, you want to use the design in the HDB, in the civil engineering, in the semiconductor. So this is different. You must have a concept. And you know the concept is based on the principle of the limited states. Next is rough setting of the elements. This one can be used in the finite element analysis, also can use in the analytical methods. So like this structure, we see this whole structure, but we cannot analyze it together, analyze all the structure at one time. So usually we will divide it one member, analyze one by one. So usually is rough setting of elements and allow for a basis on which to do rough calculations. Next is the load identification. Whether it have the wind load, whether it have the dead load, live load, lab load, or have other like the seismic earthquake conditions. So we need to consider different load. And also identify the maximum actions, or we call it the leading actions. So for example, in the building, the dead load is the dominated, or lab load is the dominated. So it considers different maximum actions. Also, this is for ultimate limited state design. For this one, maximum deflections is for the serviceability limited state design. The next is check the code, check the standards. Work to a specific design code. Check all members, check all connections. So this is the general steps. When you're familiar with steps, it's just the repeated work. Any question relating to the process here? No questions. Okay, we continue. These are some questions also for you. It's like when you design, what is achievable, economical, what delivers the required serviceability, then what delivers the required height and spans, what satisfies other safety concerns, what serves the architect's vision. So you can see also need to involve the architect's design. Because the architects, they lack some structural mechanics background. Usually they develop some quite fancy buildings or beautiful buildings, but for structural engineers, it's quite difficult for them to do. Because architects, they don't consider so much on the structural mechanics or even the load transfer functions, how the load transfer from the beam to the column to the ground. They don't care maybe so professional. And also it's like the achievable and economical. It's also the money issues. Of course, you can use a lot of materials, make sure it is safe, but it also makes sure the budget is quite high. So it's the balance between different aspects together. Okay. So the structural analysis is like real world object, drawing and sketch. May I ask whether you're quite familiar with the AutoCAD? I think civil engineer, if you work, maybe you're quite familiar with the AutoCAD. So your AutoCAD, we draw the floor plan or the front plan or set plan or other structural plan, like the column distribution, the beam distribution. So we draw that. And also the structural sketch is the column reinforced concrete distribution, the rebar distribution in the columns, so these etc. issues. Free body diagram. Still remember the free body diagram? Free body diagram. Now remember already.
Need to open the book.
Okay, I explain here free body diagram. Because it's more like the long years ago, free body diagram. Still is this beam. So if I ask you, what is the maximum deflection at this beam? You give me answers. Still remember the games? What is the maximum deflection along this beam under this load? Location. Middle span, right? But if I say I give another one, what is the maximum deflection? Maybe I give you this one, only this one you acquire from the common sense, okay, it's middle. But for this one, if I give another one, you maybe have a rough idea, it's maybe around these areas or something, but you can't give the exact location. But how can we, as a civil engineer, how can we give the exact location? We must use some professional like the structural mechanics. Structural mechanics means the free body diagram. It means, okay, this is a support. Like for example, this is pin support. We release the support first. We give the force Fx. I hope this can recall your memory of the structural mechanics issue. This also have another, maybe the civil support we cover, Fy1. So it's release the support, release the reaction support, only leave the member and also the force on the member. We call this one is a free body diagram. This is free body diagram. This usually is in year one, the civil engineering course. We will learn this one. So what we need to do based on this one is to first determine the reaction force. So sigma Fx, all the force in the x direction equal to 0. All the force in the y direction equal to 0. All the moment equal to 0. So this is the equilibrium. After we do that, we through the reaction force, we need to determine the stress using the equation, analytical way equation. We based on then a different location it will have different stress. Then based on the stress maximum value, we will get the maximum location. These are general steps how we do as a professional engineering determine the maximum location. Okay, so this is just a recall, but no need to remember in this course too much. But I hope you can learn, understand more in next course, in Wednesday course, to this one. So you can also, after this course, today's lessons, you can recall your memories of the structural mechanics. So this is how we do the civil engineering. Can you imagine? You can see before I say, okay, we now have so many softwares here. But before 100 years, we already have so many buildings. How does civil engineer do the design? They only using the hand to do the calculation. Using like this one, but not so simple. Using this analytical methods to do the calculation. So now we are more, as civil engineer, we are much easier. We just use the software, it's okay. but we still need to understand the structural mechanics between the software is better for you to check. These are all no need to remember, but I hope after this today's lessons, you can recall your slides or your notes, the free body diagram, structural analysis, the moment diagram, shear force diagram. It is helpful for you calculate for your further calculation. Then the structural design in this course mainly is identify the maximum NVM sigma. Do you remember the NVM sigma is what? Usually we use N reference what? N, and then there's M. First, we go to the M. Yes, moment. Sigma. This is called delta or sigma? I think sigma, right? Sigma, yeah. Oh, this should be not another sigma. This delta here, sigma. Let me recheck. I remember it's sigma, but I usually use delta to reference the deflection. Too many letters. Oh, delta. Yeah, remember delta. Yeah, correct. Delta. Okay. Delta is represents what? Do you remember? Again, delta represents what?
The change.
Sorry? Yeah, the change.
The change in the.
Yeah. So delta usually is mean the difference. Usually we use delta. But for me, delta this one and also delta this one represents the deflection of the deformation. So M, you know, is a moment. The next is N. N like what? Still remember? N represents what letters? N. It means the normal. Normal force. Usually we say it's the axial force. So for example, with a beam, we can bend it. We also can have the normal force. Then the V. V. Yes, V is a shear force. So usually for any member, we will have moment, normal force, and the shear force. So these are the three key forces we will calculate in the assignment or the coursework. It's a normal force, axial force, moment, and the shear force. This is for the ultimate limit state design. Then the delta is the deflection. It's for the serviceability limit state design. So recall some memories, long memories. Go back. So it's identify the maximum normal force, shear force, moment, and deflection. Then identify the code parameters. In Wednesday, you will see a lot of parameters you need to identify. Code parameters. Then perform calculation. Then based on this one, to see based on the ultimate limit state design or serviceability limit state design, check is okay or not. Okay or not. Then the overall design process is structural system selection. You want the composite structures. Still remember in the first we see the type of construction, whether it's the steel structures or reinforced concrete structures or the steel concrete composite structures. So you choose the different structural system. Then we do the structural analysis, whether you use your hand, just using the calculation by yourself, or whether you use software. Then we do the design to see whether it is safe or not, to check it is safe or not based on the codes and standards. So this is the general steps we have. Okay, actually for now, today's the knowledge actually is done already. So a summary for today's knowledge is about the design situation. Do you still remember the design situations? Design situations?
Yeah.
Reliability.
Daniel?
It was, what was it? Transient, it was.
Let's go back, we will recall. So I understand, so you already have a long. So design situation, we usually will have the transit design situation, persistent design situation, seismic design situation, accidental design situation. Okay. I should create a link. Then the principle of the limited state design. This is, I hope you can remember this one clearly. Is the ultimate limited state design, as well as the serviceability limited state design. It's like a big cover principles. All the codes or standard formulation is follow these two principles. So ultimate limited state design, serviceability limited state design, and identify which one is the ultimate limited state design, like the stability, strength, fatigue, which is the serviceability limited state design, like the cracking, fail, lightning systems, and the local damage or the durability. So understand, can identify different limited state. Next, the structural design process, no need to remember. Just like this one, hope you can go back to recall your free body diagram, structural mechanics knowledges. So this one, I hope you can learn, maybe explore by yourselves. I believe you just watch some video is already okay. Then it's different design methods. So based on what limit, based on different limits, what is the different design methods? We based on the experiments, we based on the numerical simulation, like the FE analysis, or we can only based on the analytical approach. So the different design methods. This method mainly is like the experimental test, like I showed the picture, we do the experiments, whether we're just using the ANSYS Abaqus software to do the FE analysis, or we're just using like the structural mechanics here to do the calculation. Okay, so any questions about today's knowledge about these four concepts here? All clear? Okay. If this clear, actually, we have a small tutorial. I think less than half all have a small tutorial session. You can talk each other. This also is your own coursework, but we have the courses tutorial session. Assessment section or model contains the project sketch and a 3D model. So it's working in small groups, or you can also working in your own. I will leave the free time for you to discuss and ask me questions, anything about the assignment. You need to find out, examine the drawing and the model. So that means I give you this picture, how you draw it. How you draw it, you need to think about it in the ANSYS or even in the OCAD, how you draw it. Then also identify the individual members that need to be checked. This is a course assignment. You must understand, identify the members. You need to check the resistance, whether it's okay or not. Identify different members and the load on the members, whether it is concentrated load whether it is the linear distributed load or whether it's the area distributed load for different members. So you first need to identify like the beam, column, or anything. So you list down the members you need to check, different types of members. And also identify the possible loads on those members. So this picture, maybe I sent to the group chat. Actually, you also can have it. It just give you like I think still have 20 to 30 minutes. You can do these 3 tasks. Think about it, how to drawing. Have you so you can have any question you ask me about the draw here. What's your concept? What your plan to draw this model? And also identify the individual members. You think which member you should check, the load or the resistance. And also the possible loads on those members. Okay, so time is yours, so you can start to think about these 3 questions. If you have any question, you can just ask me. I will go around to check. To give it a try, to practice by yourself. So I also want to highlight the structural mechanics. If you're not familiar, must make sure you can recall some knowledge. Like even the NVM, you must know what it meaning and how to calculate stress. This one, because in next in this Wednesday, we will have a little bit of heavy calculation. We will have 3 examples to calculate the loads on the different members. So you better to have some pre-background or recall your knowledge on the structural mechanics or the definitions on basic fundamentals. I also can send you some slides before I taught the slides about structural mechanics or something. You can do a quick check about those things. So now your task is to do this one, the tutorial session. Based on the picture I sent to the group chat, to check the drawing, the model in the video. I will ask you your thoughts. I also need to remember your names. Then I can call your names, call names to ask questions. Because the first time cannot remember clearly. is also members, structure members. So they must have load. Maybe I show example is like you no need to really drawing it on your paper. You just think about how you draw in your AutoCAD or something. So have ideas. For example, the second one is identify the members you need to calculate. For example, this one. So you can see the gray color. Maybe I use the. So for example, a third story, we have this one. Okay, so I ask you, this member it should have what type of load? This member. Yeah, if you type of load, I mean like the concentrated load, linear distributed load, or the other bending or axial load. For this one.
The roof area or which level? Roof level.
Sorry?
Roof level or which level? Slab level or roof level?
Roof level, the top level. You can see the top. I draw is like the have one beam,
Yeah.
one small beam. So should have the load on this one should be like what?
Is it only for own weight? Then consider some the superimposed loads, some live loads.
Yeah, I mean the type of load. For example, this is a beam. For example, take this out. It is support. It is supported by these two beams.
Oh yeah, it's transferred to the two beams that is load.
Yes, the load will transfer the load on this beam to the big beam. So the load on this one should be like what? It's concentrated load or uniformly distributed load or axial load.
I think UDL load.
Its own self-weight at the moment. We don't know any external factors.
Yeah, usually it is uniformly distributed on it. Then it will transfer this load because it is supported by these two big beam here, vertical beam. So if I say, okay, I ask you, this is the one type, you usually assume, okay, it's a uniformly distributed load. So then I ask you a next question. What is load looks like on this beam?
Series of point loads at each beam location.
Yes, correct. And have any other loads?
Its own self-weight because it's a uniform load of itself.
Yes.
Like the weight of the beam and then the point loads as well.
Yes. So you guys have clear about this one? Sorry, your name. Let me call your names. Yeah. You.
Yeah.
Sorry. Sorry.
YE.
YE. Yeah. Okay. Yeah. This one. What type of load for this member?
It's both uniformly distributed load because of the self-weight, and then the point load from the members coming here.
Yeah, correct. So this is I hope you do like for the tutorials, each member what have load it should have. Of course, I just take an example, it's just these two members, but also we have slabs, columns. So you need to think about what type of load it will have. Okay. So this is a tutorial. Yeah, they identify the individual members that need to be checked. Okay, continue. You do other types of members. Then if you have any questions, you are not sure the load is okay or not, types okay or not, you ask me. We can discuss, like the slabs, columns, what. Think about think it by yourself. Okay. Okay, so I call you okay, okay. Yes. Okay. have any?
Yeah, I'm rusty on columns. Beams have got in my head, but it's trying to remember how to determine
Okay.
where the columns go in.
Okay, no problem. Think about it.
That's a refresh. But,
Yes, long time ago.
yeah, because the distribution of loads in a beam type structure you come across quite a lot in a general power
Yes.
mat scenario or things
Yes.
like that. You use them a lot more,
Yes.
whereas we don't tend to get involved with the column element. It's not as transferable. You don't use it as much.
Yes.
So
Yes.
it's spreading loads across steel plates for crane platforms, all those kind of things. It's in there a bit more.
Always knowledge you don't use it when you.
Well, that's
Not
it,
so
yeah.
clear, yeah.
That's it. It just falls out of your head. So it's,
Yes. Yes. No, I just take time with you. I think computer lab is in maybe 3rd week. Then we can do the drawing. Just prepare for that. Okay.
Yeah.
Yeah.
Yeah, so as long as if we identify where the loads are and how the vectors are working on it, then it's just, if you get that bit wrong, then the rest of it doesn't work.
Yes.
So that's the bit to focus on.
Correct.
Good to remember.
Can check your previous like learning material.
Exactly that, yeah, just to get it back in the head.
Yes.
Yeah.
True. Usually, I also want to learn some like tips because I learned this also undergraduate, but in research now use so much. So I also need to go back to my learning material to check.
Yeah.
Understanding.
Yeah, it's always good to, with this kind of thing, we're going through the design process, I always find it really good to remember when I teach all of my engineers, like that thing to remember is that every design starts with a blank piece of paper. And if it starts as a bad idea, you can make it really efficient, but it's still a bad idea.
Yes.
So from a design side of things, coming up with that initial, I think this might work, it has as much constructability in it as it does numerical design. You need to have an idea of what you think might work and then check it.
Yes.
Rather than just going straight for a
True.
solution. You were saying before about like structural engineers and architects. If it was up to just structural engineers, they'd always build squares. And if it was up to architects, they'd always build clouds.
Yes.
That never work. So it's a good balance of the two.
Like you say, the share the different areas of knowledge. Yeah.
That's it. So like my early career used to be like, oh, designers are make my life so hard. Why make it so hard all the time? But as soon as you appreciate both sides. So I've never worked on the consultant side, design side. I've always been contractor.
Yes.
So I've always had to deal with bad designs, deal with good designs, and also being the bad guy, telling the designer, oh, sorry, I can't build that because it's too expensive, and redesign it because I don't like that one.
Okay.
So I get it. So it's a good balance, and doing this it helps you appreciate it more. What goes into it, why it takes so long to change that thing.
Yes.
But it's,
correct. I think your experience is quite precious, especially you have different areas combined together, different knowledges.
Yeah, especially like now coming here as well, the way that construction is done in Singapore is very different to back in the UK, where we have a lot more design and build like really close together. So you'll start construction while you're still processing the design. So you're having to be very quick, and the constructability has such an effect on how you design.
Yes.
Whereas here, a lot of the design is done, and then you go to build it, which means it's good from an efficiency point of view because the design is complete and you kind of know what you need to do. But it also means you're not able to implement changes as they come up because it's too expensive at that point. You completed it.
Yeah.
So to change a small bit, albeit it might be really efficient, it's too costly to change all the other things that have gone past.
True, yeah.
Whereas if you've only got a small part of the design, you can kind of adapt as you go along. So it's positives and negatives on both types.
Always need to balance these things.
Yes. Yeah. I always used to hate the not knowing what we're building as we go. Oh, I don't know what that room looks like. I don't know what that structure looks like yet. I know the rough shape, but I don't know the numbers.
Yes.
So it's quite hard to go.
So how many courses do you need to take?
Yeah, choosing like from now go forward.
Yeah.
That was just this one. That's all I needed to do. So it's because of what did I get when I was back in the UK? I got my chartered construction manager, which is degree equivalent.
Yes, yes.
It's not recognised here. I don't recognise equivalent. You're a chartered construction manager, you don't have a degree.
Oh,
So
I see.
it's an equivalent level of education in the UK, but because it's a different country, a different thing,
Yeah.
it just became an issue. So I just thought, well,
So later you also will go back to UK too.
potentially, I don't know. The wife's got her job here as well, so it's I really like it.
Okay,
I like
no
it here.
problem.
And they've got building stuff here forever. So
Yeah.
I think there's work here, but you can't even see the end of it. There's so much construction going on. So.
Correct, correct.
And it all looks really cool. Buildings in England are boring.
Okay. Yeah, no problem. Yeah. Hope you enjoy the short period in Singapore.
Yeah. But yeah, like any of these kind of courses, if it's not a degree course, it's a management course, it's about keeping it going. There's always something else to learn.
Yes, yes.
It's very easy to settle into what you do every day and to not get better at it or
Correct.
learn the next thing or things like that. So
Yeah.
I've always tried to change projects and learn a different type of construction, a different thing, a different view. You never know what you're going to pick up.
Yes, yes.
So you just throw yourself into, take yourself out of your comfort zone and learn something new. So,
Yeah, true, true. I also, like you, I do my research. It's also different topics, different research projects, to learn new things.
yeah.
So we can use them together to do a more better job of work.
Yeah, I would appreciate the, my wife's got a PhD in biology. When I first met her, she was doing that.
Okay.
And it was just so alien to me, like how to you focus on that for so much time on one subject,
Okay.
and like going through to the nth degree of all the different bits involved. And I'm a lot more fast-paced. This problem, solve problem, next problem, next problem. So my problems are small, but lots of.
Yeah.
Her world is a lot more big problem, long research, and
Yeah,
so
true.
it was it's quite interesting to see how
Yeah.
different operates.
Yes. Know how, see how to different things.
Yeah. There's no one answer. There's always many different ways to do it.
Yes.
Good to learn. So
Yeah. No
I
problem.
don't mind it.
Okay.
This one will stop.
This is not
stop.
Okay.
Can I leave?
Oh, okay. So I think today's lesson almost there. So if you have any questions, remember to email me or WhatsApp me. So I'm here to help you to go through this course. So if you don't have anything or nothing to discuss, you can leave now, I think. Okay. Thank you very much. Thank you. So I'll take the attendance already, right? Okay. Mel Coco, we finished 30 lessons. So if you have any issues or problems, just email me or contact me.
Oh, just one question. Just how the model structure is making by ETF or just using the SketchUp?
I think this model the draw is using SketchUp, but no need to draw lah. You will draw it in the ANSYS.
Oh, yeah.
Okay, thank you. Bye.
Okay, thank you. Bye.
Okay, bye bye. Take care.